to transfer the data from the RFID tag to the RFID system, especially between the RFID tag and RFID reader. There are several tag air interfaces defined by the GS1 or EPC Global. The tag protocol have been defined for using within the EPC Global network and several under development. In this semester, we focus on the UHF Class 1 Gen 2 tag protocol and the HF High Frequency Gen 2 tag air interface. The ultra high frequency UHF Class 1 Gen 2 tag air interfaces is a ratified EPC Global standard. It also a ratified ISO standard, while the three other tag air interfaces were published by the Auto ID Center prior to the creation of EPC Global. Due to the purpose for supply chain using the EPC Global select and define the UHF Class 1 Gen 2 RFID tag to be used for the EPC network framework. And that's because the most environment within the supply chain will be a metal environment. No matter the logistic, delivering, warehouse, most of this environment will be metal environment, and we need the RFID tag with higher performance to be work at this type of environment. So we select ultra high frequency. And because the EPC Global select and define the tag protocol UHF, so company A and company B, even they don't have the same RFID reader hardware, they can still install the RFID tag by themselves. Maybe even the company are located at a different country. Fortunately, the EPC Global already defined the 860 to 960 MHz for the UHF RFID tag. So if the company registers itself in the EPC Global organization and follow the standard or tag protocol air interface, then the RFID reader still can install the RFID tag, so the information can be obtained or the tag can be identified by the RFID reader. So the tag air interface indicates how to communicate a command to a tag from an RFID reader. Since there are different types of RFID readers and different company would product the RFID reader, so how to communicate between a tag and a reader, especially to send a command from the reader to the tag, will be defined in the tag air interface. In opposition, how to communicate a response from the tag to the RFID reader that issued but a comment. Since we send a comment from the reader to the tag will respond and will reply the corresponding information to the RFID reader. So the communication between each other should be defined by the tag air interface. The third, how to provide means for a reader to singulate individual tags when more than one is within the range of the RFID reader. Because we already know that the RFID reader can induct the RFID tag, many RFID tags simultaneously. So at the same time, there are many RFID tags would receive the signal command from the RFID reader. So which one RFID tag will reply the information and provide the means for a reader? They will be very important. So finally, how to provide means for readers and tags to minimize the interference with each other. That's also defined in the tag air interface. Since there are many RFID readers and more and more RFID tags within the induction range, so this wireless signal is broadcast in the air. So you need to reduce or minimize the interference between signals. And how to minimize the interference, that should be defined in the tag air interface. Since we hope the RFID tag can be used for the logistic supply chain delivering, then the joint tags, RFID tags, far more than mere barcode replacement. We can try to use RFID readers, especially you can locate the RFID antenna at the specific location. Then the RFID reader can induct the RFID tag automatically, periodically, so the information can be obtained and stored at the remote database. Considering the environment today, UHF Class 1 Gen 2 has several uses, such as identifying the tags in an inventory, although without a video camera, we cannot make sure what the trade item inside the inventory. However, at least we can know where is the inventory and when it is inducted, so the manual operation can be reduced. Second, if we try to involve the existence of the maybe artificial intelligence or the customized service, we can read in user memory for additional item information. For example, when you buy a beer, even you buy a red wine, the information will present it to you which kind of the meat or the beef or the steak would be suitable for this red wine. The additional customer service or information can be given. The third, writing travel history and the destination into the baggage tag. So when you deliver the traveler's baggage, you can send the baggages to the correct airplane. Today, many airports already involve the RFID system. They have the existence of the RFID system for delivering the traveler's baggage. Hong Kong Airport already used the RFID tag many years ago. There are too many baggages need to transfer from one airplane to another. So even the RFID tag cost, however, it is much cheaper than the airport delivering the baggage wrong. So it is worth. And the Hong Kong Airport already used the RFID system for delivering the baggage. So storing an in-service data into bag and locking it. Finally, displaying or killing a tag before the consumer checks out. That's because we need to pay attention to the security issue and the privacy issue. If you do not display or kill the RFID tag, it means other people or even a stranger can use the RFID reader to induct the RFID tag inside your house. Then what you buy, when you buy, and where you buy the trade items with the RFID tag will be provided to the stranger. There will be no security and no privacy. It is dangerous. So before the RFID tag leave the gate, the store, before the consumer checks out, the RFID tag should be killed or should be disabled. In the early 2008, the UHF ultra-high frequency spectrum was available in more than 55 countries with around 15 additional countries in the approval process. So finally, the EPC Global tried to define the spectrum which can be used for the RFID tag, especially at the UHF spectrum. And this broad availability of the UHF spectrum ensure the same RFID tag can operate worldwide. You can find that Europe use the UHF Gen 2 RFID tag around the 816 to 817 megahertz frequency. In the United States, the spectrum of the UHF Gen 2 RFID tag will be located from the 900 MHz to the 913 MHz. In Asia, Japan used the spectrum located between the 950 to the 960 MHz for the UHF Gen 2 RFID tag. Because the spectrum will be occupied maybe radio station, or military service, so it is not easy to find the same spectrum for all the country to use the RFID tag. Hence, the EPC Global define from the 860 to the 960 megahertz spectrum for the RFID tag UHF Gen 2 operation. And today, it is also the most popular RFID spectrum using worldwide. This slide presents the Taiwan specification of the RFID. The NCC already defined the usage and utility of the radio frequency identification. If you want to use the RFID radio frequency identification in Taiwan, the operation spectrum will be located within 922 to 928 MHz. Follow the definition of UHF RFID spectrum defined by the EPC Global. So if your RFID reader can read the tag between the 860 to 960 MHz, it means the RFID reader can be used in the RFID system in Taiwan. If you want to use the RFID indoor, you can only use the max about 1 watt power and less than. Okay. If you locate your RFID system outside to keep other people safe, because many people were afraid of the electronic magnetic wave, so the power will be reduced to a 0.5 watt power. But in fact, if you have the specific purpose, for example, at the highway, you use the EPC, then the ETC will induct the tag on your car, pass the inside or pass outside your car. The power of the RFID reader will be large enough to induct the tag with a longer distance. So it depends on your implementation environment. So how do a RFID system engineer to select the operating frequency? Since we have a low frequency, high frequency, and ultra high frequency RFID tag, these three types of the frequency will provide a different performance in the corresponding environment. So you want to create a RFID system with higher performance, you need to select the suitable RFID frequency. As we have learned, the operating frequency will directly impact the performance of the RFID system. Therefore, the main factors that you should consider when selecting your operating frequency are your application requirements and the operating conditions. The read range, RFID reader induction range requirements for your application will give you a very good idea as to which frequency you should select for your system. Most application types, for example, warehouse management, have a common set of requirements and are therefore associated with specific frequencies. You should finally also factor under which conditions your system will operate, as higher frequencies are more subject to the interference and problems with materials such as liquid or metals. Due to the frequency, the length of the electromagnetic wave also change. So the higher frequency means shorter length of the electronic magnetic wave. So depends on the shorter wavelengths, the antenna can be designed smaller. It also means the RFID tag can be designed with the smaller size. So you will find the ETC freeway RFID tag is small. But if you use the low frequency LF RFID tag, the RFID tag will be large. The size is large, very larger than the high or ultra high frequency RFID tag. And also depends on the power from the RFID reader. The higher frequency, even the ultra high frequency, can have the larger or longer reader distance. So even use the ultra high frequency RFID tag passed on the car, we can still induct the RFID tag with a longer distance. Then you can use your ETC and drive your car on the highway, especially since the frequency is very, very high, even ultra high. So the RFID reader can induct and read RFID tags, multiple RFID tags simultaneously, almost at the same time. The tag data can be transmitted very, very quickly at the fastest transmission speed. However, the moisture, the water, the liquid will decrease performance of the RFID tag with higher, even ultra higher frequency. So we already mentioned in the past course, the lower frequency will have better performance in a moist environment. So low frequency LF, high frequency HF will give you better performance than the ultra high frequency. But if you want to implement RFID system in a warehouse, in a metal environment, you need to select ultra high frequency UHF to get better performance. So you need to consider the implementation environment. No matter the induction range, the induction simultaneously, how many RFID tag will be inducted at the same time, and the liquid or moisture environment versus the metal environment. That will affect the performance. In other words, you should not implement the RFID system first. You should consider the environment first. Then you can design your RFID system corresponding to the environment for the higher performance. The EPC Global continues to develop additional tag air interfaces to satisfy the additional needs. It includes the HF Class 1 Gen 2, UHF Class 2 Gen 2, UHF Class 3 Gen 2, and UHF Class 4 Gen 2 RFID tag. And it depends on the need provided by the industry or the supply chain. For example, if you want to record or storage more information into the RFID tag, especially you want to protect the information recorded in the RFID tag, then you may need to use the Class 2 Gen 2 UHF RFID tag because it provides more user memory to record the information. Especially, it also provides data protection and access control. Or, similar to we mentioned in the past courses, you can equip the battery, provide the power to the sensors. And finally, you can even use the battery to provide the power to the RFID tag. So the UHF RFID tag will become the active RFID tag. So the tag air interfaces under development include the UHF Class 2 Gen 2 based on the existing Class 1 Gen 2. As an extended tag ID, extended memory, data protection, and authenticated access control. The UHF Class 3 Gen 2 is a UHF specification for sensors and battery tags, built upon existing Class 1 and Class 2 Gen 2. And finally, the UHF Class 4 Gen 2 becomes an active RFID tag. So, what is Class 1, Class 2 to the Class 4? What does it mean? Here, we give you the EPC Global Tag class definitions. The Auto ID Center at the Massachusetts Institute of Technology (MIT) has defined an RFID class structure to provide a framework for the discussion and the development of RFID tag functionality. From this structure, EPC Global has developed tag class definition describing the functionalities of the RFID tags in each of the 4 classes. Class 1 RFID tag will be a passive RFID tag. It has the basic functionalities as they generally only provide or give the identity information. The Class 1 RFID tag only contains an EPC number to identify the trade item, object, or product, and the tag ID to identify the tag. So, Class 1 indicates an RFID tag with only EPC tag ID numbers for the identity purpose. They also have embedded a function that renders the tag permanently non-responsive. Optionally, they can have user memory, password protect, access control, and the possibility to decommisses or recommisses the tag. So the Class 1 may have the memory and the basic password protected access control. However, if you want to encrypt the user memory, rewrite the information into the RFID tag, you need the Class 2 RFID tag. The Class 2 RFID tag are also passive RFID tag with additional features above and beyond those of Class 1 RFID tag. There are extended RFID tag ID, extended user memory, and an authenticated access control. So some information can be read, not only read, but also write into the memory. In a Class 1, the memory is only to be read. But Class 2, now you can encrypt the data, you can read and write the memory. So who can read and who can write? Who has the right to do the access? That's very important. And the Class 2 RFID can provide the functionalities. In the Class 3 RFID tag, It is mentioned in the past courses. The Class 3 IBD tag is a semi-passive IBD tag. A semi-passive tag will have a power source and supply the power to the sensors. So the Class 3 IBD tag can have sensors with the optional data login. It can collect the corresponding information. The last one is the Class 4 IBD tag, which will be the active IBD tag. An active IBD tag will have the power resource, not only provide the power to the sensor, but also provide the power to the tags. So the IBD tag, Class 4 tags can have access to a transmitter, so that they typically can initiate communications with a reader or with another IBD tag. Protocol may limit this ability by requiring a IBD reader to initiate or to enable the tag communications. Class 4 IBD tag shall not interfere with the communication protocol used by the Class 1 or 2, even 3 IBD tags, since it already can communicate with each other or with the IBD reader automatically and actively. So the number of the class increased. It means the functionalities or abilities to do the communications will be more actively. And these are the 4 types or 4 definitions of the tag class. Remember that the Class 1 and Class 2 both are passive IBD tag. Class 1 provides the basic identity information, and the Class 2 provide the read, write, and access control. Class 3 is a semi-passive IBD tag, provide power to the sensors. Class 4 tags will be an active IBD tag. Then you can remember these 4 types of the class. So how can we do the anti-counterfeiting? Since the IBD tag will be assigned a unique tag ID and a corresponding EPC code, serial code, EPC manager code, object class number, then the IBD tag will only store or assign the unique tag ID. Especially, this unique tag ID cannot be rewrite. Okay, this tag ID is unique and cannot be rewritten or to be reset. In other words, the IBD tag all over or in worldwide in any supply chain will be unique. No any 2 IBD tag will have the same tag ID. Especially according to the definition In the EPC global network, the EPC code consists of the EPC manager number, object class number, and the serial number will be unique. So one unique tag ID will be assigned to one individual trade item. So based on the unique ID, we can trace and track to find the original manufacturer. By search the RFID information, we can collect the whole product history. According to the information, then we can know this trade item or this object is true or just as a copy. So we can enhance the anti-counterfeiting in the supply chain.